Welcome guys. So the reason why I'm making this video and a few after this is my grade 11 babas is writing about grade 10 quantitative aspects of chemical change now in the June exams. And this is just for revision to make it easier for them to remember what I have learned last year. I want to start this with a little story about Freddy. So Freddy woke up one morning, he took his cup of coffee, he went out to his backyard, he looked over his lawn, and there he saw a little heap of soil. And he wondered, where did this heap of soil come from? Then he remembered what he had learned in grade 4. It is a mole. Alright Babas, so as Freddy went to investigate, for some reason he spelled mole wrong. And he got to the examination guidelines for grade 10. And there he read that 1 mole is defined as the amount of substance having the same number of particles as there are atoms in 12 gram carbon 12. So to calculate mole, there's going to be 4 formulas that you're going to see on your formula sheet. So the 4 formulas is what I'm going to talk about in this video. So the first one is going to be mass, small m, over molar mass, capital letter M. Then the next one is going to be mole equals to the number of over a constant which is known as Avogadro's number. Then the next one after that is when we're dealing with gases. So it's going to be volume over molar volume. That is also then a constant. And then the last one, I'm not going to say equal, I'm going to make a little arrow like that. It's where we're going to have concentration equals mole over volume. So let's jump into the 4 formulas. First one first, it's mole equals mass over molar mass. So mass is where we measure it in grams. Usually it's a given. If it's not a given, they will give you the mole itself. And then the molar mass is then measured in grams per mole negative 1. So that is usually a given. If not, mole will be a given, or you have to calculate it. And then the molar mass itself. The molar mass is where we're going to need our periodic table. So usually it's the bottom number, which is the relative atomic mass number, the bottom number there. Now, say if we use an example H2O. With H2O, we're going to look hydrogen. Its atomic mass is 1, but there is 2 of them. Plus, then we have oxygen. So oxygen here is 16, the mass. So it's 16. We're going to smash that into our calculators. It's going to be 1 times 2 is 2. 2 plus 16, it gives us 18 molar mass, grams per mole. Alright, that is number 1. Then the second formula is mole equals number of. It stands for number of. I want to say number of stuff. That is the key word that we have to look at. It's number of atoms, number of particles, number of molecules, the number of. And then that's going to be divided by a constant, as you're going to get it on your formula sheet, the constant of Avogadro's number. And that number on the formula sheet is going to be 6,02 multiply 10 to the power 23 mole, and remember the negative 1. Alright, that's number 2. Number 3 is where we're going to deal with a gas. Now with a gas, we are going to look for the acronym, or if they're going to say it, STP. When you see that, we know we can use this formula. So it stands for standard temperature pressure. Volume is measured in cubic decimeters. Remember your 3 there. And then molar volume is a constant on your formula sheet, which is then going to be 22,4 cubic decimeters per mole. Remember your negative 1. And this is when we are dealing with a gas. STP, a gas, constant, and we can calculate mole equals volume over molar volume. Then the last one is the one of concentration. So it's concentration equals mole over volume. Volume, you see it there? Let's take a different color. So this volume is cubic decimeters. Mole is of course measured in mole. And then our concentration is measured in mole per cubic decimeters. Per means negative, then your 3. That is then our concentration. And a concentration is when there is a solution, and then we can calculate concentration in a solution. So concentration on your exam guideline is defined as the number of moles of solute per cubic decimeter of solution. Alright, Babas, that is the 4 formulas that you need to be able to do to calculate a mole. So the next video I will do small easy examples, and then I will start to jump into what we call stoichiometry, where when you calculate 1 mole, we can use a ratio to get another mole. Thank you for watching.